Question 1. The 30 kilogram pipe is supported at A by a system of 5 cords as shown in figure 1. Determine the force in each cord for equilibrium. On the right side, this is image of free body diagram at point A. First, we solve the Fy first to get the TAH and TAB. TAH now this is equal to 294.300 Newton and we got TAB 339.828 Newton. After that, we insert the TAB in Fs and we got TAE equal to 169.914 Newton. Now, we will solve at point B. At point B, we know that TAB equal to TBA equal to 339.828 Newton. Now, we went to find the TBA on X and Y axis. TBA on X axis is 169.914 Newton and TBA on Y axis is negative 294.800 Newton. After that, we find the total of Fy equal to 0. And we got TBD equal to 490.500 Newton. After that, we solve the Fx. Now, we got TBC equal to 562.314 Newton. And now, we put all the result we got, and here, the force on each cord. Thank you.
Assalamualaikum. My name is Nurul Aisyah binti Muhamad Aliman. Today I want to explain about question number 2. The goal of this problem is to find the internal force in 3 specific members of this truss, which is ED, EH and GH. To do this, I will use the method of section because it allows us to cut the truss and solve for only the parts we need. This is free body diagram. Before we cut the truss, we need to know how the ground is pushing back at the supports. I look at the wall truss and took the south moment at point A. This means I multiply every downward load by its distance from left side, which is 30 times 2 plus 40 times 4 plus 40 times 6 equal to 460 kilonewton meter. To keep the truss from rotating, the upward force at the right end must balance this out, which is point F. By dividing the total twist by the full 8 meter length, I found that the support reaction at Fy is 57.5 kilonewton. Now, I draw a free body diagram on the right hand section. I imagine cutting through the truss vertically between joints D and E. This leaves us with a small triangle shape. We have the 57.5 kilonewton pushing up and the bottom and a 40 kilonewton load pushing down. The 3 cut members ED, EH and GH act like internal force holding this piece in place. Now, I solve for the 3 unknown using equilibrium section. For member GH, I took the moments at joint E since the other 2 member points right at E. They disappear from the mat. I found FGH is 76.7 kilonewton. Because it's pulling away from the joint, it is in tension. For member ED, I took the moments at joint H. This left me with member ED. The result is 100 kilonewton. Since it is pushing into the joint to stabilize the load, is in compression. For member EH, I balance the vertical force. I use the angle of the member to find its vertical 29.2 kilonewton. It is pulling away, so it's tension.
Assalamualaikum, my name is Puteri. So here is the question that I got for this assignment. So right now, Let's take a look at this problem where to find the horizontal and vertical of the forces at spin B and spin C. What are we looking for are the reaction at spin B and spin C. Notice that they are both part of the member CB. So here is the free body diagram. At spin C, we have two reactions, which is Cx and also Cy. The directions are assumed. Now, as you can see, the member AB is a two-force member. That means the resultant force at B will be like this. The angle can be found by using the inverse of tangent. And here is the tension of cable. So we have three unknowns here, which is the force AB and also two reactions at C. We can solve the force AB if we write a moment equation about point C. Only y component of force AB creates a moment since the x component goes through point C. So we have x component of force AB times the perpendicular distance. Then we have the force applied at the top of the pulley and also the force applied at the pulley on the bottom. 2.8 is coming from the sum of the radius and also the perpendicular distance. Since we assume clockwise to be positive, the weight of the cylinder creates positive moment about point C, while the other forces create counterclockwise moment, meaning that they are negative. Now we have two unknown left. To find the y-axis, we can write an equation of equilibrium for the y force. So we have the y component of force AB, pulley, and Cy. To find the x reactions, we can do the same step like how we find the y-axis of forces. We have x component of forces AB, pulley, and Cx. Now, since we need the xy components of reaction at B, we need to break force AB into components. We can do that by using the angle we found. And those are the answers. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira, Syahira binti Samsuri. Today I would like to present about question 4, which is friction force. This is the given question for the assignment. Okay, as we can see from this figure, we can take out the friction force Ft, and the mu s for BD is 0.3, for A and C the mu s is 0.3, and for A and B the mu is 0.4. Okay, from this diagram, from this figure, we can separate it. Okay, I will start with which B first. For which B, we can take out the friction force, which is 0.3 multiplied with normal force of D, and then there are normal force here, and then for the friction force here we can assume it, which is friction force E, which is 0.4 equal to normal force E. And then there are two unknown, which is NE and D, and we have to take out the calculation, which is from here normal force we can get like this. The equation for take out this is sin equal to opposite divide with hypotenuse, and then we get normal force E sine 15 and normal force E cos 15. Same like for the 0.4 normal force E, and then we get like this, which is equal to this. And then from the waist B, for the Fy equal to 0, which is this one, acting downward, so it is negative. And then Ne cos 15, and then 0.3 ND, 0.3 ND friction force here, and then 0.4 Ne sine 15. And then we get first equation, and then we go to Fx equal to 0. Fx equal to 0, which is ND is negative because we assume to the right is positive, and then Ne sine 15 and plus 0.4 Ne sine 15 cos is equal to 0. And then from these two equations we solve using calculator, and then we get this value. After that, for wedge A, we write down the mu s prime 0.4, and then the friction force is here, and the normal force of E is, we assume E here, and then we have get the answer for Ne. Then we replace here, and then we got 10794.148 Newton. For Fc 0.3 NC, and there are normal force here, and then we take out from Ne here, and then we got cos Ne cos 15 and Ne sin 15, and for Fe is here 0.4 Ne sin 15 and then 0.4 Ne cos 15. And then we move to the equation which is Fy equal to 0, and then we got from the answer, we replace here cos 15 plus this one, and then plus NC equal to 0, and then solve all of this using calculator, and then we got this. For Fx equal to 0, we got P, and then replace with Ne sin 15, subtract with 17 this one, and then cos 15, we replace NC with here, and then we got P equal to 454.37 Newton, and then it is the smallest force of P needed to lift the 3000 load, and then we got the answer. That's all from me. Thank you.
Hello everyone, here is Wong, and now I would like to talk about the Set B assignment question 5, which is about the centroid. So based on this question, for finding the location S wide of the centroid, first we need to find the total length first. So as you can see that, first we need to find the total length. We need to add all of the segment lengths here. You can see that here, and we got 235 millimeters. Yeah, we need to add these, all of them. So after that, we need to find the multiplication of the segment length with the horizontal length from its center to the level of the origin, which is here. Yes, here's our origin. So as you can see this table, how we could find its center. So let me give you some example for the segment 1. So for the segment 1 is here. So as we need to take the center here, from here to here. So we got 7.5 is its center length to the origins here. So for the next, I give you example for the segment 2. So for the segment 2, we can see that its center is here, but it's located in the same level with the origin horizontal level. Yeah, it's same here. So we got 0 here. So I give you another one example which is more special. So which is the segment 7. So for the segment 7, here we need to take the center here and towards this origin. So here is the 50 mm and here is the 50 mm. So and its center is 7.5 mm. So we got 37.5 mm here. And after that, multiply both of them for each segment. So we got this one, 5737.5 mm squared. So from the vertical component 2, we use the same ways. So as I can give you some example too for the segment 1 too. For the segment 1, as you can see, the segment 1 is here. It's same level as the origin here. Its Y position is same with this. So we assume that it's the 0 mm. For the another one, I give you 7.4. For the segment 4 here, its center is here. So to reach to the origin that, we need to plus this 50 mm with its center here, which is 7.5 mm here. So we got it 65 mm here. So and the width is same for all the segment here. After that, you do for this, you need to multiply it together and plus all of them. So for the Y, we got 9550 mm squared too. So after that, we need to find the answer we want, which is the SY position. So for this, we use the same formula here, which is here. We use this answer divide to the dotted line here from the S position. So after that, we will got 24.41 mm here. For the Y position too, use the same formula with this, which is use the Y position here and the total length. After that, divide it, we got 40.64 mm here. This is the final answer we wanted. Thank you.